Okay, oxidation of alcohols. Oxidation is defined as the removal of electrons from a species. You can see that difficult to say where the electrons are removed from when we look at an organic molecule though. This O in square brackets means oxidation, and this particular reaction we've got ethanol going to ethanal. Well, we can extend our definition of oxidation to addition of oxygen or removal of hydrogen. If we look here, this molecule ethanol has got 6 hydrogen atoms, where the ethanal has got 4 hydrogen atoms and the same number of oxygens and carbons. So we're actually losing 2 hydrogens. And so our definition of oxidation fits in terms of addition of oxygen or removal of hydrogen. We can, however, do the traditional count up to get the oxidation number of the carbons in the structure. We consider that each hydrogen is worth +1, oxygen is worth -2, and the sum of all oxidation states must be 0. We do our sums down here. 2 carbons plus 6 hydrogens plus 1 oxygen gives 0, and this gives us carbon with an oxidation number of -2. A similar treatment for ethanal finds that the oxidation number of carbon in ethanal, or each of the carbons in ethanal, is -1. And so we've gone from -2 for the carbons to -1. It's less negative, and so we are losing electrons. In fact, each carbon is losing 1 electron, so overall there are 2 electrons being transferred. In fact, ethanal can also be oxidized by exactly the same oxidation conditions as ethanol. So we have to be very careful here that if we want to make ethanal from ethanol, we must prevent this further oxidation. And this is done by removing the ethanal from the reaction vessel as soon as it's formed. We'll see how that's done in just a moment. There we go. In order to make ethanal from ethanol, well, we perform the reaction in our round bottom flask here, for example, connected to a jacket condenser full of cold water coming in here, water coming out here, so that as the ethanal is formed, it rises up, goes past the thermometer, and recondenses in the reaction in the jacket condenser and drips into our conical flask or whichever vessel we have receiving it. This is possible because ethanal has a much lower boiling point than both ethanol and, if it further oxidized, the ethanoic acid. In order to make ethanoic acid, we just must prevent the ethanol leaving. We see the 3 boiling points here. Ethanol is 79 degrees, ethanal is 21 degrees, and ethanoic acid is 120. So you can see that if the temperature is kept above 21 but below 79, we should get ethanal being produced. However, if we have the apparatus arranged so that the water jacket condenser is vertical, the ethanal will recondense inside this water jacket condenser and fall back into this vessel. This is known as refluxing. It's a very well-known technique for ensuring maximum temperature of reactants in an organic reaction. If we have a look at the oxidizing agent that's normally used, it's potassium dichromate 6 in acidic solution, and this is the equation for the reaction here. Dichromate ions pick up 14 hydrogen ions, 6 electrons, and become chromium 3+ ions and 7 water molecules. So this is balanced in terms of particles and in terms of electrons. It's quite a useful reaction because we can actually see the colour change as the dichromate gets reduced to chromium 3. It turns from orange to green. Secondary alcohols are not oxidized in the same way as primary alcohols. Primary alcohols make aldehydes, but because a secondary alcohol has got only 1 hydrogen attached to the carbon that holds the OH group and 2 carbons, it means that the carbonyl group that's going to form here is in between 2 carbons. In other words, it's in the middle of a chain. This is called an alkanal or a ketone, and propan 2-ol will oxidize under the same conditions as propan 1-ol. It will oxidize to propanone. And once we get here, there's no further oxidation possible because there are no hydrogens attached to this carbon. And for the same reason, tertiary alcohols cannot be oxidized at all. There are no hydrogens attached to the carbon that holds the OH, the hydroxy group. Well, this allows us a means of differentiating between primary, secondary and tertiary alcohols. Primary alcohols will oxidize directly to aldehydes. We can use distillation to remove the aldehyde if we wish, or we can carry on using reflux to re-oxidize the aldehyde as it's formed to a carboxylic acid. Secondary alcohols, however, go straight to ketones, and from there they can go no further. Whereas tertiary alcohols, there is no oxidation possible.